Let's take a look at part 2 of the digestive system. Our learning objectives for this slideshow is to take a look at the steps and process of digestion, to look more in depth at mechanical and chemical breakdown of foods, to also be able to identify the name, shape, and location of the digestive tract accessory organs, and to also know the function of each of these organs as it relates to digestion. Just a quick side note, we will be talking just about the dog and cat throughout this presentation. We won't be doing the comparative that we did in the last one. So the steps of digestion are ingestion, so taking food into the body, propulsion and peristalsis, or moving that bolus of food or chyme throughout the body, the mechanical breakdown of food, chemical breakdown of food, and then the absorption of the nutrients in their most basic form, and of course then defecation of any waste materials. Let's take a look at those a little bit more. Ingestion is commonly called eating. In our healthy patients, they would take their food in through their mouth. Smell for some species, particularly the cat, plays a huge role in whether or not they will eat. Cats who have an upper respiratory infection or otherwise can't smell often won't eat. So it's important to know in the veterinary feline patient that if you have a cat who's not eating, it may be because they can't smell. But once food is in the mouth, that's when the digestive process starts. We have the teeth, the salivary glands, and the tongue that contribute to this process. Teeth, of course, mechanically start to digest our food. Salivary glands are chemical, so they provide saliva, which has an enzyme in it called salivary amylase, which starts the breakdown of food as it comes into contact with it in the mouth. The tongue is kind of mechanical more than anything because it's there to mix the food and mix in the saliva that is produced by those glands. And so the tongue is mechanically not really breaking the food down, but more of a mixing of the two things to help accelerate the chemical digestion that's happening through that salivary amylase. As the tongue mixes the food with the saliva, a bolus is formed. And a bolus is what we call this wad of food that has saliva mixed in it that goes from the mouth down the esophagus into the stomach. Peristalsis is the wave-like muscular movement of ingestion throughout the alimentary canal. From the esophagus to the stomach, we call that a bolus of food. So the bolus of food is food mixed with saliva, and it moves down the esophagus into the stomach through peristalsis. Once it's in the stomach, we call this bolus of food now chyme. Once it's been in the stomach for a little while, it's mixed in with the stomach enzymes and the stomach acids. It's now broken down even more, and the consistency is not really recognizable as food at this time. It's kind of like pudding, if you will. Once it leaves the stomach through the pylorus and goes into the duodenum, and now it's in the small intestine, we're going to still call it chyme for its entire travel down the peristalsis throughout the entire small intestine. Peristalsis then brings it into the colon, and now once it hits the colon through the cecum, we're going to call that feces or stool. And so the entire time it's moving through the colon through peristalsis, that's called feces or stool. Mechanical breakdown is the teeth, what we primarily think of as the teeth, ripping and tearing and chewing. Now we talked before that a lot of times our veterinary patients aren't actually chewing their food. And that's okay because we give them a commercial diet. There's really no need for them to chew that. A cat with no teeth can live just fine on dry kibbles. They just swallow the kibbles down and then they do coat them with saliva. That bolus gets to the stomach. It turns into chyme as it's sitting there with the acids and enzymes of the stomach. The tongue is part of mechanical breakdown as well, mixing that food bolus, or maybe just pushing it down the esophagus into the stomach. The stomach, of course, itself also has the ability to help with mechanical breakdown because it does itself peristaltic contractions of the bolus that's sitting within it. So it actually pushes from the fundus we talked about before, and contracts down through to the pylorus and mixes and mashes the food, being a big participant of mechanical breakdown as well. Chemical digestion, this is the powerhouse of digestion. This is where food that comes into the body is actually able to be broken down into small monomers that can be absorbed by the body, which is going to be the next step. Enzymes and acids are there to chemically break down food into their molecular components, which is what we need for usable nutrients or calories. Chemical digestion is done by the stomach, the liver, and the pancreas primarily. Of course, the saliva, having salivary amylase does help support that, of course, but these are the powerhouses, the stomach, the liver, and the pancreas. You can see that the stomach, this is actually a dog schematic on the side here, which is great. We can actually see more what a canine system looks like. The stomach is circled in yellow. It's that big organ, of course, that can hold a lot of material. And just below that is the pancreas. The pancreas lies just below that. It actually wraps itself around the stomach, but it's connected to the duodenum, and we'll talk more about that in just a second. Here's a great schematic. It's kind of cartoonish, but it really gives a good view of where these organs lie. So if you have a dog standing here, we can see that giant liver, which wasn't pictured in the last slide, but that giant liver hiding behind the stomach. And I think I have a laser pointer that I can use here. So this is the liver here. And then we have the gallbladder, which lies up tucked into the liver. And then we have the pancreas right here. And then, of course, after that, we have the small intestine, which connects to the colon, and then the rectum, and then out the anus. Just kind of a fun little skip. Let's start with the stomach. The stomach produces digestive enzymes and also acid that chemically break down the food. Pepsin is the primary enzyme that's produced by the stomach to break down proteins in particular. So pepsin, P proteins. Pepsin is going to break down proteins starting in the stomach. You may have heard of a medication called Pepcid. Pepcid is used to actually reduce the production of acid in the stomach. And so if you can remember Pepcid is used for stomach upset, then you can remember pepsin is the enzyme that is produced by the stomach. These fluids within the stomach are very acidic. So in dogs and cats, the pH is typically between 1.5 and 2.5, and so very low on the pH scale. And that's due to the hydrochloric acid that's produced by the stomach. Hydrochloric acid in its pure form can dissolve bone on its own. It's obviously diluted within the stomach, but the stomach itself is coated, remember, with that mucosa to protect it from the hydrochloric acid that it itself produces. But a lot of chemical digestion starts in the stomach and breaks down this big bolus of food, and often with our dogs and cats where they don't even chew it, breaks it down into this mixture, this kind of pudding-like mixture of chyme that's then going to go into the small intestine and get more chemical digestion. The liver is the next step in chemical digestion. It's a large vascular organ. It actually has 4 lobes and it has a ton of jobs within the body. So just talking about its production of bile, which is what contributes to digestion, is a very small part of what the liver actually does. It produces this bile, though, which is this milky, yellowy substance that travels down the hepatic duct to the bile duct, and then it finally either goes right into the duodenum to help with digestion, or it goes into the gallbladder for storage for later. Bile is an alkaline fluid, so unlike hydrochloric acid, it's alkaline, so it has a high pH, but this aids in digestion, and in particular, bile is going to break down lipids or fats. A really fun fact about the liver is that it can actually regrow portions of itself. So as long as 25% of the liver is left, it can actually regrow its lobes, which is a really, really interesting thing about the liver. The gallbladder is this cystic-like organ, so it's like a bladder, if you will, so just like a bladder, the urinary bladder, I mean, and it hides up behind the liver, and again, it's where the bile is stored, the overflow from the liver. So it has its own little duct, the cystic duct, and the cystic duct connects into the bile duct, which then goes down into the duodenum. It happens through contractions. So contractions of the gallbladder actually release bile into the alimentary canal to help with digestion and right into the duodenum. So on our little graph here, or our little graphic here, this part here is the duodenum. So that's going directly in. We're going to talk next about the pancreas. So you can see the pancreas actually goes right into the duodenum as well. So here's another image of the pancreas. We looked at this one already where it's all tucked up in there. This is a really, really fascinating organ. Again, it is a lot of things for the body, just like the liver. The gallbladder is kind of a one-man show. All it does is provide bile, hold bile, provide bile. Sometimes it gets stones, which cause pain and discomfort to the organism. But this is a glandular organ, so it's actually all made of glands, and it has 3 parts to it, and each part actually has a little bit different function. These parts can be called lobes, most people call them lobes, and it has a head, a body, and a tail to it. A portion of it lies kind of up and behind the stomach, but then the head is connected to the duodenum, and then by the bile duct, and so that's where we see that the pancreatic fluids actually go into the duodenum. So the pancreas produces trypsin, amylase, and lipase, which are digestive enzymes. So again, it has many other roles. You probably remember learning that it also plays a function, plays a role with insulin and diabetes. You hear about that. But the main focus we want to talk about is the trypsin, amylase, and lipase. Again, trypsin, amylase, and lipase are the enzymes that are produced by the pancreas. This graphic here, again, really love it. It's that same little dog we had before with a cutout for these organs. So we can see better how the duodenum is here and how the pancreas actually connects into it and actually feeds into the common bile duct that goes into the duodenum. Pretty cool. So trypsin is going to be the enzyme that breaks down protein. Amylase is going to be the one that breaks down carbohydrates, and lipase is the enzyme that breaks down fat. I think lipase is the easiest one to remember because we know that lipo is the root for fat, so lipase is going to break down fat. And then trypsin sounds a lot like pepsin that we just learned breaks down protein, so the P, protein. So trypsin and pepsin both break down protein. And then amylase is the last one, and that's going to break down carbohydrates or sugars. And I don't know, I have a really good friend named Amy who is an actual gummy worm fiend and loves sugar. And so remembering that Amy loves sugar, so amylase is going to break down sugar, might be a good way to remember that one. Absorption is the almost last step to digestion and the absolute most important part of it. Now, absorption could not happen without all of the other parts, but absorption is what the whole thing is about. This is what everything is about with eating and with digestion. And that's the process of moving nutrients from the digestive tract into the bloodstream. Now, the big question is, where does this happen? It happens primarily in the small intestine. The small intestine is where most of our nutrients, us, the dog, and the cat, are absorbed into the body. Now, the stomach can do a few things. A lot of medications actually get absorbed by the stomach. Some toxins get absorbed by the stomach. So you can kind of think of it that way. But our nutrients are going to be absorbed through those microvilli in the small intestine primarily. The small intestine can take in fats, can take in proteins, can take in sugar, can take in water, and vitamins and minerals. Those are all of our essential nutrients. Where the colon, who also has villi and microvilli, only takes in water. So if you think about it, what sits in the colon is stool, it's feces, it's already waste. So most of the nutrients have already been taken out of it. But what needs to be taken out of it is water because it needs to become more solid. And so that's why you can remember that the small intestine, the longest part of the entire digestive alimentary canal, is what is the primary absorber of our nutrients. That is where most of our nutrients are absorbed. The duodenum is very short, but it does a lot to break down our nutrients. And then the jejunum, which is quite long, it's the middle part of the small intestine, and it's very long. It does a lot of absorption because our chyme sits in that space for a very long time on its way to the ileum and then to the cecum and then out through the rectum and anus at the end. And just because I love this picture so much, I had to show it one more time of all of these little villi that go up and down and up and down and up and down in the small intestine. And again, this is a cross section. So they actually took a piece of small intestine, cut it like a garden hose, and then squished it on a slide, stained it, and looked at it under the microscope. This part up here is the lumen. That is where there, would be chyme within our system. This down here is the actually outside, or the serosa, if you remember, and then the mucosa in here. And then these are little spicules for amazing villi and the microvilli coming off of them. Just so cool. And again, it comes right there from the small intestine. So the last step here is defecation or elimination. So what's in feces? It's just waste. It's indigestible material that forms into feces in the colon. So it went from chyme in the small intestine to feces in the colon. It travels through the colon through peristalsis, and during this time, water is removed. Microbes that are in our colon are actually providing fermentation to undigested material as well. And then the stool sits in the rectum, and then once it's signaled to the brain, the rectum signals to the brain, oop, we got to do something about this, then it passes through the anal sphincter. There's actually two anal sphincters. There's an internal and an external. And once it hits the internal, that's when the body says, or the brain says, okay, we've got to do something about that. And it's released from the body. And that is the process of digestion.